Hi all, welcome to my fifth lecture in probability. In the previous lecture, we were discussing something called binomial distribution, and we shall be continuing with binomial distribution in this lecture. In the previous lecture, we had understood how to evaluate mean in binomial distribution. Now we'll see how to find out the variance in binomial distribution. This is how variance is represented. Sigma square is given by summation m minus m bar square times fm, where m bar is the mean value of the random variable, m is the value of the random variable, m minus m bar would give me the deviation, and the square of deviation is m minus m bar square. Fm is nothing but the probability. This is the expression for variance, and we need to evaluate in the case of binomial distribution what this turns out to be. Okay, from the previous lecture we know that m bar was evaluated as NP, where n is the total number of trials and p is the probability of success per trial. Therefore, my sigma square will be m minus np the whole square times fm. Now if I just open this bracket, I'll be getting m square fm minus twice mnp fm plus n square p square fm, all within summation, and the summation goes from m equal to 0 to n, and if we just look at this expression, the summation is over m, so you can take np out of the summation. Here also n square p square comes out of the summation. Now I already know that for any probability distribution, the sum of all probabilities should be 1. So this term just becomes n square p square. Okay. And we also know that summation mfm is nothing but our expectation value or the mean value of the random variable, which is m bar. And what is m bar? M bar is nothing but np. So using these two relations, we have this equation as sigma square is summation m square fm minus 2np times this quantity, which is again np. So you get np the whole square, and here you have 1 np square. So my expression for variance turns out to be summation m square fm minus np the whole square. You give it as equation 3. Now you need to evaluate summation m square fm, which appears on the right hand side of equation 3. Now for that you consider this relation. Summation mfm is np. Okay. Now what is fm? Fm is the probability distribution function, which is ncm p raised to m 1 minus p raised to n minus m. For binomial distribution, this is the probability function. And right hand side you just leave it as such, np itself. You put it as equation 4. Now you differentiate equation 4 with respect to p. We are just following the same steps that we used to find the mean value m bar. Okay, so you differentiate this equation with respect to p, and it just turns out to be like this: m times ncm, it remains as such. Then you take this as a constant and you differentiate this, you get this term, and then you take this as a constant and differentiate this, you get the second term, and on your right hand side you just get n. Okay, now again just doing some rearrangements in the terms. First term remains as such, and here you have an n minus m. You open that bracket and you have a term containing plus m p raised to m, then the remaining part 1 minus p raised to n minus m minus 1, and then you have a minus n times the same things, bracket close, and this is equal to n. Now what did we do in the previous lecture while evaluating m bar? After you differentiate everything, you multiply it by p into 1 minus p, right? So we do that here also, and you see that your term becomes something like this. It is m square ncm p raised to m 1 minus p raised to n minus m is already there, and the extra 1 minus p you write it separately. Then when you multiply by p into 1 minus p, you already have a p raised to m in this term. So you write the p separately. Then your 1 minus p, the power becomes n minus m, because you are multiplying with p into 1 minus p. And then you have this term which contains n, that becomes m ncm n p raised to m 1 minus p raised to n minus m, and this is equal to np into 1 minus p. Okay, you just write it down and check for yourselves, and after some simplification, you see that there are so many terms common over here. P raised to m into 1 minus p raised to n minus m is common. You take it out of the bracket, and within the brackets you are left with 1 minus p plus p. Okay, and here you have np will come out of the summation, and remaining, what do you have within the summation? M is there, ncm is there, then p raised to m into 1 minus p raised to n minus m is within the summation, and on your right hand side the same term itself, np into 1 minus p. Now from equation 4, what was equation 4? Equation 4 tells me that m times fm is np, where fm is this thing. I have a same term here, right? M times fm. This is equal to np. Okay, so I plug in equation 4 here, and I have first term is like this, and I have minus np times np. Okay, now you take this term to the right hand side, and I have now what is this thing? This is fm. So I have summation m square fm is nothing but np the whole square plus np times 1 minus p. ഇക്വേഷൻ 5 എന്ന് ഇടുക. അപ്പോൾ നമ്മൾ സ്റ്റാർട്ട് ചെയ്തത് തന്നെ എം സ്ക്വയർ എഫ് എമ്മിന് ഒരു റിലേഷൻ കണ്ടുപിടിക്കണം എന്ന് പറഞ്ഞിട്ടാണ്. ഇക്വേഷൻ 3യിൽ എനിക്ക് റൈറ്റ് ഹാൻഡ് സൈഡിൽ ഐ ഹാഡ് എൻ എം സ്ക്വയർ എഫ് എം. ഈ എം സ്ക്വയർ എഫ് എമ്മിന് ഒരു എക്സ്പ്രഷൻ കണ്ടുപിടിക്കാനാണ് നോക്കിയത്. ആൻഡ് നൗ വി ഹാവ് അറൈവ്ഡ് അറ്റ് ഇക്വേഷൻ 5 വെയർ we have found out an expression for m square fm. അപ്പോൾ ഈ കിട്ടിയ എക്സ്പ്രഷൻ ഇക്വേഷൻ 3യിൽ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം. Now what is equation 3? That is what I have written here. Equation 3 is sigma square is equal to summation m square fm minus np the whole square. ഇങ്ങനെയായിരുന്നു ഇക്വേഷൻ 3. അതിൽ summation m square fmന് പകരം ഇപ്പോൾ കിട്ടിയത് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം. And then you will get np the whole square plus np into 1 minus p minus np the whole square. Okay, np whole square cancels and you are left with np into 1 minus p. Now what is 1 minus p? 1 minus p is nothing but q, which is your probability for failure. P is the probability for success, and n is the number of trials, total number of trials. This is your variance. Okay. So sigma square is given by npq in the case of binomial distribution. Now what's the standard deviation? Standard deviation is square root of variance, and your standard deviation for a binomial distribution is root of npq. I hope this was clear. Thank you all.